So in the first paragraph containing question number 17 and 18, it is given that a coil of inductance L connects the upper end of the two vertical conducting parallel rails separated by a distance d. A horizontal conducting connector of mass m starts falling with zero initial velocity along the bars without losing the contact with them. The whole arrangement is placed in a uniform magnetic field B perpendicular to the plane of the arrangement as shown. The resistance of the whole arrangement is negligible. So in question number 17, we have to find out if I is the current through the inductor and A is the acceleration of the rod, then the correct graph is R. And in question number 18, we have to check the validity of given options. Let at any time t, the rod is at this position and let its velocity is v in this direction and the acceleration is a. Then I can write mg is acting in this direction. Since it have a velocity, so the induced EMF will come across its end. L into di by dt is equal to VBL. So the velocity is v, b is magnetic field, and the length of the rod is d. So this is the induced EMF across the ends of the rod. So since the magnetic field is inside and the velocity of the rod is downward, so this end becomes positive and this end becomes negative. So the current in this circuit is anti-clockwise, and due to this current, the rod will experience a force BIL in this direction. So if I write the equation of the dynamics, then I can say mg minus BIL. So B into I into L is D is equal to mass into acceleration. And the second equation which we have is L into di by dt is equal to VB into D. So this equation can be further written as L into di by dt is equal to B into D into dx by dt. So on integrating this differential equation, we will get L into I is equal to B into D into x. So this is a straight line equation passing through the origin. So option A is correct. Now we have to find out what is the relation between A and x. So in order to find out the relation between A and x, it can be written as A is equal to G minus B into D by M into I, and the value of I can be substituted from here, that is B into D into x by L. So from here we can see that the intercept on y-axis is positive and the slope is negative. So option C is also correct. So the correct answer for question number 17 are option A and C. Let's move to question number 18. In question number 18, the motion of rod is a simple harmonic motion of angular frequency. So we have to find out what is the angular frequency. So this is omega square. So from here we can easily find out it is equal to b square d square upon ml. So the value of omega is bd upon under root ml. Is option A is correct and B is wrong. Now we have to check the validity of option C and D. We have to find out what is the amplitude. So in order to calculate the value of amplitude, we know that at the mean position the acceleration becomes 0. So if I calculate the value of x, then from here it comes out to be mg into L divided by b square d square, and we have started this motion from here, so we can say that when the acceleration becomes 0, the value of x gives the amplitude. So the correct answer for question number 18 is option D. So option D is also the correct option. So the correct answer for question number 18 are A and D. So in this paragraph, the correct answer for question number 17 is AC, and for question number 18, it is A and D. Let's move to the second paragraph containing question number 19 and 20. In the second paragraph containing question number 19 and 20, it is given that a coherent parallel beam of EM waves of wavelength lambda is equal to 0.5 mm falls on a Young's double slit apparatus. The separation between the slit is 1 mm, that is equal to D. The intensity of microwaves is measured on the screen placed parallel to the plane of the slits at a distance of 1 meter from it, as shown in the figure. In question number 19, if the incident beam falls normally on the double slit apparatus, the y coordinate of the interference minima on the screen can be. The path difference when the waves are falling on the slits is 0. Let at any point P the path difference between the interfering wave is d sine theta. Let this is d sine theta. So for the condition of minima, we can say that d sine theta must be equal to 2n minus 1 into lambda by 2. Now in the given question, the value of lambda is d by 2. So if I substitute the value of lambda as d by 2, then it can be written as sine theta is equal to 2n minus 1 divided by 4. Now if I apply the condition of sine theta, that is less than or equal to 1, then from here we get the value of n, that is less than or equal to 2.5. So the possible value of n is n equal to plus minus 1 or plus minus 2. If I consider the value of n is equal to 1, then the value of sine theta 1 comes out to be 1 by 4. In that case, tan theta 1 comes out to be 1 by root 15, and that is equal to the position of minima y1 divided by capital D. So the position of y1 comes out to be capital D, that is 1 meter. So 1 by root 15 into meter. Similarly, when the value of n is equal to 2, then sine theta 2 comes out to be 3 by 4. So the value of tan theta 2 comes out to be 3 by root 7, and that is equal to the second position of minima divided by capital D. So the value of second position of minima comes out to be 3 by root 7 meter. So option A and option C are the correct answers. So the correct answer for question number 19 are option A and C. Let's move to question number 20. In question number 20, if the incident beams makes an angle of 30 degree with x-axis, then y coordinate of minima is. So when the rays are incidenting at the slits S1 and S2, then they already have a path difference of d by 2. So we can write in this way, d by 2 into sine theta is equal to 2n minus 1 into lambda by 2. So where the value of lambda is d by 2. So if I substitute the value of lambda is equal to d by 2, then sine theta comes out to be 2n minus 1 divided by 2. And if I apply the condition of sine theta, that is less than equal to 1, then the value of n comes out to be less than equal to 1.5. So the possible value of n is plus minus 1. So in this case we can say that the position of central maxima is at an angle of 30 degree with this axis. So this is the position of central maxima, and this position can be found out. So this is equal to tan 30 degree is equal to, let this y naught, so this is equal to y naught divided by capital D. This is equal to 1 by root 3. So this position y naught can be found out as 1 by root 3. Now for the y coordinate of minima, the path difference P1 can be written as delta x1, that is equal to lambda plus lambda by 2. So it comes out to be 3 lambda by 2. So in that case, sine theta 1 comes out to be 3 lambda by 2 divided by d, and if I substitute the value of lambda as d by 2, then it comes out to be 3 by 4. So tan theta 1, that is equal to 3 by root 7 is equal to the position of minima, that is y1 dash in this case, divided by d. So from here the value of y1 dash comes out to be 3 by root 7 meter. So option B is correct. And in the second case, if the path difference comes out to be lambda minus lambda by 2, then in that situation it is equal to lambda by 2. So the sine theta 2 comes out to be lambda by 2 divided by d, and if I substitute the value of lambda as d by 2, then it comes out to be 1 by 4. So in that case, tan theta 2 can be written as 1 by under root 15, and this is equal to the second position of minima y2 dash divided by capital D. So in that case, y2 dash comes out to be d divided by under root 15. The value of d is 1, so 1 by root 15 meter. So option A is also correct. So the correct answer for question number 20 are option A and B. So in paragraph 2, the correct answer for question number 19 is option A and C. And in question number 20, it is option A and B. By this, I wish you all the best for your preparation. Have a good luck. Thank you.